Welcome to Chapter 11, Lesson 6. Now, in Lesson 5, you learned how to multiply fractions. And Chapter 11, 6 is just more on multiplying fractions. So just a very brief review, okay? In Lesson 5, you would learn a problem like this, where x divided by 5, or x over 5, times 10 over x plus 1, you would be able to factor out or cross cancel as we did in just simple arithmetic, okay, and get the 10 equal to the 2, the 5 is a 1. You end up with 2x divided by x plus 1. And because you've done your canceling out before you multiply, you don't have to simplify at this point. You also had problems that look like this. Now my job always, I look at the numerator and I say, can I factor anything out? There's no GCF here. It's a binomial, but there's nothing squared, so I know I don't have the difference of squares, so I'm done. I look at the bottom, I only have 2y, which is 2 times y, and I can see that it's already factored, essentially. 3x, the same, okay? And if I look at the very bottom of the right-hand fraction, I see I have 3x minus 6y. Well, this one I can see that if I take out the 3 as a greatest common factor, I would have x minus 2y left. And I usually just try to write that right underneath the fraction, and then I have it right there. Okay, now at this point, I can cancel out what is in common. Okay, so I have x minus 2y, and I have x minus 2y. Okay, remember, if you have a minus sign or a plus sign attaching two things together, then the entire group has to be able to go. In this case, the entire group is enclosed by parentheses, and it matches that entire group. So I can ditch those because they're acting as factors. Okay, now I also have a 3 here and a 3 here, so I can get rid of that. So my final answer is simply the only thing I have left in the numerator, which is an x, over the only thing I have in the denominator, which is 2y, which is a lot more pleasant than my original problem. You could also have a problem like this. If you had x plus 2 times x over 3, you need to remember that you have a fraction here, even though you don't see a bottom to it. Okay, now the nice thing about multiplication is that you do not need a common denominator. You just simply multiply the numerator by the numerator and the denominator by the denominator. Now in this case, again, I would look to see if there was anything to factor out. X plus 2, I can't factor that. 1, clearly not. X, no. 3, no. Okay, so the only thing left for me to do is simply to multiply. And so I go ahead and do that. And actually, because there's no factors, I can just leave that as my final answer. You could also write the numerator as x squared plus 2x, but if you leave it in this factored form, then you can glance at it and you can know without a doubt that you can't eliminate anything and that you're completely done, which is always a nice feeling. Let's look at another problem that's kind of similar, okay? If we had 4x times 4 over x minus 4, okay, I'm going to put this 1 on the bottom, and I know I'm going to multiply my numerator by my numerator, and again, I can glance at this and see there's nothing that I can factor out. So I'm going to end up with 4x times 4, or 16x on the numerator, and then just simply x minus 4 on the denominator. There's nothing else I can do. There's no factors I can get rid of, and so that is my final answer. Let's look at a different kind of problem that you're going to have. Now your book is going to show you these problems and expect you to solve these two different ways. Now one of the ways to solve it is simply by doing FOIL. And if you did FOIL, then you would simply do your first times your first term, which gives you x squared. And then you would do your outside term, which would give you 5x over x, your inside term, which would give you x over x, and then your last term, okay, which in this case would give you 5 over x squared. Now you can see that the middle term can be simplified. So you could have x squared plus this 5 plus that 1, which was 6, plus 5 over x squared, okay? And that would be your final answer if you foiled that multiplication problem. I'm going to show you the exact same problem, but I'm going to show you a different method for solving it. Okay, now this method just would ask you to take this addition problem and make it into one fraction. In other words, you're kind of combining what you learned about addition or subtraction of fractions and then also applying it. So in this case, I need to have a common denominator. I'm going to use a different color pen so you can see what I'm doing. Not that you couldn't see brown, but that's okay. All right, now I know that my denominator on both of these is 1, okay? And I need to have a common denominator, which clearly is going to be x. So I'm going to rewrite this one as x squared plus 1 over x. And I'll rewrite this fraction, or this little addition problem, as x squared plus 5. Just kidding, over x. Now when I do that, then I unfortunately have to solve this, which seems like an ugly kind of ordeal, but it is possible. I'm going to do FOIL now, okay, with my top. So I'm going to do x squared times x squared, which is x to the 4th. I'm going to do my outside, which is 5x squared. I'm going to do my inside, which is simply x squared. And then my last term is simply x. And all of this is over x times x, or x squared. Now, of course, I can simplify these. And I'm going to write, I don't want you to do this on your paper because it's just so messy, x to the 4th plus 6x squared plus, I'm just kidding, this is 5, what am I thinking, plus 5. And that's all over x squared. Okay. Now I'm going to show you the answer that we got when we FOILed it and the answer that we just got by doing the problem. They are actually equal to each other, even though they don't look like they are. Remember, in one of our lessons we took and we said that we could represent each of the things that are in the numerator over the entire denominator. So in other words, this whole problem could be represented as x to the 4th over x squared, and 6x squared over x squared, and 5 over x squared. And of course, this could be changed to x squared, and these could cancel out. And then you can see how this problem, x squared plus 6 plus 5 over x squared, equals that one. It's just kind of a strange way to do it, but it really does work. So just be careful as you continue your multiplication and have some fun with it. Have a great day.